Hi guys, welcome to the first video on time series. And this is basically a series of projects. So in this first project, we're going to do auto-regressor analysis. So in this particular video and in this particular series, we will understand the basics of time series. We'll understand different categories, not all the categories of time series, but different, but a very few and very specific fields. And this will basically create a foundation for you for the later advanced versions of time series. So let's get started with the project. So the agenda for this particular video and this particular series would be first we'll give you an introduction about what time series is. Next, we will understand the basic rules around time series. We'll understand that what are the basic misconceptions which has been followed, and how is it different from a regular machine learning project or regular data science project that we do on a day-to-day basis. Then we will understand what the pre-processing of data is. So time series has a different way of pre-processing the data, and there are few of the discrepancies which was not there in the previous projects or in the other projects that we have done in the field of data science. So this is a pre-process lecture. So in this particular part, we'll understand that. Fourth is the plots. So there are various plots, and we'll understand that how to plot a time series, how to modify and how to modify a few of the parameters, how to keep the important parts out, and we'll understand that how to plot those particular parts. Next, we'll understand the categories and tests. So there are multiple categories and standards in time series. And then we'll understand autoregressor and rolling windows. So I won't go in this particular video, we'll just cover the introduction. But this is basically the agenda for this time series. All right. So time series introduction. So we're going to discover how it is different from other type of data as you've previously encountered and why. So time series modeling is a special kind of data set. This is a special kind of data set and this is a special kind of modeling that we do. And in this particular series, we'll understand that how we can model the data for years, for centuries, for decades, and other things. And our main goal is to find the pattern in that particular data. As you can see over the picture over here, right, we see that there is a pattern. There's this pattern which is going up, and then there's going somewhere else. But there's a pattern in which the data follows, and we'll understand this pattern. We'll understand that how we can actually model these particular parameters, how we will understand and pre-process these parameters. So what is time series? So time series is a sequence of information at, which attaches a time period to each value. So it is some kind of measurable value. It's a sequence of information, one after the other, as you can see over here. So this is the key feature to highlight here is the sequence. So sequence is something which time series thrives on, and sequence is basically which we are keeping. So it is basically a sequence of information which attaches a time series to each value. The value can be pretty much anything measurable. So it can be anything. It can be, it depends on the time in some way. Like it can be a prices, it can be humidity, it can be a number of people, it can be anything, but it has a time attached to it. So let's say today's temperature is 30 degrees, tomorrow's temperature is 40 degrees, and so on and so forth. So it's like every particular row has a time attached to it. That is why it is called a time series. As long as the values recorded are unambiguous, any medium could measure with the time series. There aren't any limitation regarding the total time span of the time series. So we don't have any kind of limitation, as I mentioned. So we can have data for centuries, we can have data for decades, we can have hourly data, we can have we can have seconds data, we can have any kind of data that we can think of. So there's nothing a limitation, as it is mentioned in the next statement, that it could be a minute, it could be a day, it could be a month, it could be a century. All we need is a starting point and an ending point. All right, so that is all we need for a time series. And between the starting and ending point, this there can be a GBs of data, there can be TBs of data, there can be anything. But our main goal is to analyze that particular data, find the patterns, and then understand the time series and then go ahead with that. So if you see in the image over the right, this is in the x-axis you can see years is 1990, 1995 to 2000, 2005, 2010, and so on and so forth. Same way you have some of the values which is being forecast. So this can be a, stock related data, this can be any other data, but this is how we basically plot a time series, and this is how it usually looks like. It can have different patterns out, but this is basically how it looks like. Analyzing time series in a meaningful way. All the time periods must be equal and clearly defined, which should result in a constant frequency. So the time series that you're capturing, the data that you're capturing should be clearly and equally defined. It shouldn't be like in the initial four values you have taken each day, and the next four value you have taken each month. It should not be like that. So all time periods. So time periods is basically the term. So time periods must be equal and clearly defined. This frequency is a measurement of time and could range from few milliseconds to several decades. So you can like just capture data from, okay, so this is 1 decade, 2 decade, 3 decades, and so on and so forth. But the difference between the each time period should be same. Furthermore, patterns observed in the time series are expected to persist in future. That is why we often try to predict the future by analyzing the recorded values. So the pattern that we observed, the things that we observed in this particular time series. So as you can see over the image to your right, we have different patterns. We have the pattern like this, which is clearly random. We have another random pattern cannot be this dense. The values can be different. The lower one that you can see is seasonal, so it's like it is forming a cycle, it is forming a regular pattern, so it's easy to predict that okay, this is something which is going to happen in future. And this is and the lower one is basically a random pattern. So the first one is the observed pattern, second is a trend, so it is just following a trend, which is often the case in the stock markets. The seasonal is the cycle which is repeating, which is the case with the seasons in general. So the weather is something which repeats over the year, right? So if you plot the data for each day for the entire years for the 365, and if you plot the data for 10 years, you will see the cycle like this. That is why it is called as seasonal, which is being derived from this particular term. And random is nothing but it's a random thing, and we have multiple examples for that. All right. So furthermore, the patterns observed in the time series are expected to persist in future. That is why we often try to predict the future by analyzing the recorded values. If the data is not ordered chronologically, so this is basically the term chronologically, finding the correct pattern would be extremely difficult. So if it is not ordered chronologically, so let's say the initial values are taken in days and next value is taken in weeks, then it months, so it will be difficult to analyze a value, right? So it is strongly suggested, and it is not suggested, it is basically a rule of thumb that the data should be chronological. Okay. For instance, simply knowing the highest temperature of last 5 days would be useless unless we got unless we got a series of data for the entire month or entire year. All right. So this was basically the introduction of time series. And what are basically the application of time series? The time series data is largely applied in finance sector for investors, for companies owners. So you might have came across and went into a stock market website in which there's a lot of graphs and there's up and downs, and all there is time series that how this particular stock has behaved for a span of an year. Okay, it is crucial to determine whether the prices, returns, profit, sales will increase or decrease in future. So let's say if we are plotting for some uh, ice cream selling, so the sales will go down in the winters and it will go up in the summers. This means the values for each period are not only affected by outside factors but also the values from the past period. So we can also, so this basically can follow the past period as well. For instance, we expect tomorrow temperature outside with somewhere reasonably proximity to today's temperature. Yes, it won't be like today it's 30-degree hot and tomorrow it's like 0 degree. It won't be like that, right? So that is basically an application for time series in which the data not only depends on the on the outside factors, but it also depends on the past factors. And there are multiple use cases like elections, supply chain, advertising, health management, weather forecast, earthquake prediction, and so on and so forth. So everything in this world follows a cycle, and our goal is to find that particular cycle and make predictions out of it. That is all for the video number one. We'll see more topic and we'll understand more about time series in the future videos. Thank you and have a nice day.